For this session right now, we have David, and he will be talking to us about taming the data tsunami. Over to you, David.
Hi, everyone. I'm Dave Aronchick. I'm a longtime open source guy. I was the first non-founding PM for Kubernetes, and I led that for a bunch of years. I started the open source machine learning project called Kubeflow. I've been doing stuff in NumFocus and PyData and so on for years. I love being here, and I've given these talks before. I always just really enjoy the audience, so I really appreciate the opportunity to talk. Today, I'm going to talk about a problem that I think gets not anywhere near as much attention as we need to. You know, we're basically spending all this time and energy building these agents and doing really creative things, and I really want to give credit because there has been so much advancement in the space of machine learning and making machine learning useful. But I think the problem that we're missing here is how much data feeds into that. And I'll get to exactly what I mean here. But I think people really need to think through a strategy or a playbook on how to address this in a much more aggressive way. So to start, sorry, my screen is very small here. This is the agenda. We're going to talk about this problem that I'm going to bring up over and over again called the ingested all tax. It is the default today. I'll explain what this looks like. And then I'll talk about some of the ways that I think the open source machine learning playbook, the open source data playbook has advanced and how we might change things. I like to offer this. This is not a joke. If you are a business who's interested in working through any of the solutions that you see here, I am employed at a business. This will be an entirely playbook and non-commercial related, but I am more than happy to talk to you about it, even if it's just talk about the open source tools that I talk about today. I'm happy to do that. Scan, enjoy. Okay, data. I always thought when you're giving a talk to start with something that everyone agrees with. We agree with data, right? And we agree that it's getting bigger. Makes sense, right? But then you're like, okay, but so what, right? Haven't we been facing this challenge for a ton of years? And the truth is we have, right? However, there are three problems that are happening now that I think might be unique, or at least certainly unprecedented. The first is that data is growing too fast. And by that I mean, the IDC estimates that 175 zettabytes of data will be created today. That's so giga, tera, peta, yada, I think is next, and zetta is after. Who wants to correct me? But regardless, it's like several ones beyond where we are today, right? Several orders of magnitude bigger. And that's how much we're creating this year alone. And it's mostly going unused. The Gartner estimates that just 29% of the data that an enterprise collects is actually even looked at once, right? It's just kind of crazy. I mean, on the other hand, you're kind of like, actually, that's true, right? I got like 16 servers over here, and they're all generating these like random server logs, and nobody really looks at them. Maybe I go in and debug one if it's like flapping, but most of the time it just goes off to whatever, Splunk or Datadog or whatever, and nobody looks at it, and as long as it's not an error, no problems. Well, this is generally okay, except if you get to numbers like I was talking about on the last slide, and especially now that machine learning teams are looking for data not to be redundant, data to be clean and useful and well schematized and have lineage and provenance. If you're just spitting out noise, it no longer just becomes free to store. If you want to make it useful in any way, then you're now asking the people downstream who are building the models to think about it. And then you get to the point where it's like hard to centralize. So I said as kind of like a throwaway, well, all right, you're just going to hand it to Splunk or Datadog or whatever, but it's not that easy anymore, right? Those platforms are still great. I'm not taking a single thing away from them. You're going to need a high performance, high volume data warehouse. No question about it. But right now, the playbook is ingest it all, and then we'll deal with it. Put it in bronze tier. Don't worry about it. We'll figure it out from there. And then all of a sudden your CIO comes down and is like, what the hell? Why is my bill 10x what it was last month? Your CISO is like, are you scanning this stuff? Remember log4j that like nearly tore down the entire internet? That was because people were ingesting raw logs without sanitizing them at all. Your lawyers come and say, hey, by the way, did you move PII? I have no idea. I literally have no idea. Like, it just threw it in there, and now it's in my bronze tier. Guess what? Your bronze tier is now poisoned. and potentially in violation. So there's lots of reasons not to ingest it all. And what I would say is the fundamental flaw here is that we apply control too late in the process. The stack is powerful. VMs, containers, functions as a service, data stack, or the data stack we have, the orchestrators we have. These are all fantastic, but those are all so far on the right of your overall pipeline, so close to actually the generating of the data. And you're leaving all of that control that you should have applied the moment you get in. You're kind of like, you're sitting in your bedroom and you're wondering why there's a bear attack, and it's like, well, your front door is open, right? Did you even think about like closing the front door? Oh no, but I locked my bedroom door. Well, you know what? There's a lot easier way, right? And then you're like, okay, well, if it's not AI/ML, go away. But I would argue that this is fundamentally the ML challenge that we have today, right? It means your supply chain is broken. Your costs, your training costs are higher than they should be because they're training on unnecessary data or poorly structured data. It's slow to experiment. It's slow to discover that, oh, by the way, this data that we trained on actually should have been cleaned in a following way, meaning you have to go back out, you have to go clean it again and then come back. Your model is degrading. A lot of times you don't even know your model is degrading. You're just like, why is this taking so long? Or why is the performance bad? It's because you have completely unweighted data. Like you have a ridiculous amount of perfectly normal information in your model when in fact you needed something more specific. And like I said, we haven't even begun to see the wave of lawsuits around governance and things like that. If you can't identify exactly what the data that your model trained on, where it was collected, how it was collected, what policies were enforced, congratulations, your entire model is poisoned, right? You now need to tear the entire thing down. Like, God help you if you don't have that kind of information. And let me tell you, most people don't. So I like to say there's a modern path for modern data processing. Again, everything you see on the right hand of the slide, I am not a customer or whatever, an endorser of any of those things. They're great. Keep using them, I promise you. But let's think about what is at that arrow and to the left. How do you pull things in from multi-region, multi-cloud? How do you pull things from edge, IoT, on-prem, whatever it might be? Oh, don't worry, I'm not doing self-driving cars. I'm not doing edge sensors. Guess what? If your VM isn't in the exact same region as your data cluster, congratulations, that's effectively an edge device. You had to move data and logs across a country, a state, whatever boundary, network boundary, into your new location, and it's more likely than not you lost provenance, you lost information. That would have been valuable for your eventual debugging. So we faced this challenge before in the machine learning community, and again, NumFocus and the stuff that data folks have done has been tremendous. I would argue it started with just like, hey, it's really hard. Like, I don't want to understand matrices and matrix multiplication. Like, can't I just operate things simply? That's when Pandas comes along. Again, enormous congratulations to that community for really moving the entire world forward. Then you're like, okay, I can run my one Pandas job on my machine, and I have the superpowered machine. What do I do next? It's still taking forever. That's where things like Dask and Spark come along, allow you to do much more simple, distributed training, distributed data processing mechanisms. Then you say, okay, well, accessing my data is too slow. Like, I have all this compute power. How do I get access to it? That's where you get things like Apache Arrow and so on. You're being smarter about storing it in memory. And now you get to this final step, or not final, again, once we solve this, by the way, there's going to be something new, horrible coming along. But the next big blocker, I would argue, is this, right? I need to fill those data stores that are now highly efficient, that are ready for compute, with clean, schematized, secure, reliable, tracked data. Just help me fill it smarter. And I would argue that that's where we are now. This is a bottleneck. It's not a bottleneck that a lot of people are paying attention to, because they can go and they can look at their Snowflake bill or Databricks bill or whatever it is, and they're like, bill goes up, linear, hey, all good, we're storing, until you go talk to any data engineering team, and they're like, oh yeah, by the way, I spend 73% of my time just cleaning because nobody remembered whether or not this thing was in euros or dollars, right? So like, it's a pain. And it's funny, I give a lot of talk to CIOs, and they're like, no, we're good. I was like, really? Like, I promise you, I'll bet you, whatever, $100, If you go talk to your data engineering team right now and you ask them, are they spending even 50% of their time on what you asked them to instead of just keeping the lights running or making sure this pipeline that broke last week has like been repurposed or reused or fixed? I guarantee it's the latter. So I would argue we need a new playbooks. I was struggling with this slide because it's like I wanted to make a joke about like needing more than one, but like then the A doesn't sync with the plural. I don't know. I gotta workshop this one. So I would say the new playbook based on the facts. I love basing things on facts, things that can never change. And I would argue these three elements on the left will never, ever, 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 ever change, right? One, data is everywhere. No matter how much we want our entire business to exist inside a single data center in Oregon, it does not. You have things in multiple places. You have things on-prem, you have things cross-cloud, you have things everywhere. All of that is collecting data. So we need to be able to store and query that information where it's being generated. Now, it doesn't mean that's the only place, but you're going to need to do that. Second, speed of light is constant. Near as I can tell, I'm not a physicist, but I think that's a pretty good thing to bet on for the future. And as a result, that means if you want to do real-time things, if you want to be faster than the time it takes to move data across something, across a boundary, you're going to have to be thoughtful about what to move, when to move it, how to, what to do where and what location. And third, regulations and data gravity exist. And they will continue to grow, that's my thesis, but even if they don't, just what we have today is plenty. And you need to be thoughtful about never moving certain types of data because they will never pass regulations. And we need to think about that. So these are the three playbooks I'm going to walk through. As I said, promise, $50, sign up, strategy session, all yours. So let's do playbook number one. Data is everywhere. So when I say everywhere, I really do mean everywhere. A lot of people are like, well, I'm not edge. And like I said earlier, if you have an Ethernet cable, congratulations, you have a distributed system. You have edge, right? Like you have two things that need to stay in sync. You have things being generated on one thing that move to a second thing. It's the way it works, right? That's how we get things to operate together. And a centralized data warehouse cannot be the only answer. Now that doesn't mean it's not part of the answers. Too many people are like, well, I'm going to get rid of all centralized data warehouses. I'm going to have this super rich distributed query system and so on and so forth. No, that's wrong too. The only wrong answer is absolutes. Self-referential, meta, whatever. But that truly is it. If you say all of one or all of the other, you're probably not doing it correctly. And some of the ways it shows up for you, high egress costs, maybe things take a long time, they're slow, they're non-performative, they're hard to debug remotely, really a lot of operational overhead because too many people are just like, don't worry, I'm just going to ship, and call it a day. So the idea is instead, think about an architecture as part of this playbook where you're not moving all of the data into your central warehouse. This is a term that I don't know if I'm trying to coin it or whatever, but like I call it near compute, which is basically like be thoughtful about moving to a general place that is nearby where you're generating the data in order to do initial steps of your things. Now you can write in that location to a highly queryable, highly efficient place where it might be append only. And I'm an enormous fan of Parquet and Iceberg and things like that to achieve that. But then it gives you a lot more options on what to move. Now, because you're in a queryable state, you don't have to write raw, whatever, Perl parsers for your system log. You can be smart about it and say, okay, I'm going to do this and I'm going to issue some queries, and then I'm only going to move results, or I'm going to be thoughtful about how to move it. Some of the open source tools that I recommend here, open table formats like Iceberg and Delta Lake and Hootie are terrific. There are tools for federated queries, some where you have like a universal federated solution where you hand a query to it and it will find the location. Others where instead you're just aware of the different tool or different network topology you have out there and you issue a single query to all of those places, and then wait for the results, either locally or as a result. And DuckDB is a wonderful tool for that. And then, of course, in-memory work. Apache Arrow is terrific for this. But basically, you want to be thinking language agnostic because some of your people are going to use Python, and some are going to use JavaScript, and some are going to use Perl, and so on. How do you encapsulate what their logic is, but allow them to execute against your overall system? So the layout for this, the topology for this looks something like this. This is a retail example, and again, if you're like, oh, I'm not retail, I'm not open, whatever, I'm not in commerce, like, you could put any box over there, right? You could put US East and US West. Like, it's the same thing. In each of those places, you have whatever, IoT, or you might have VMs, or whatever it might be. It's coming off. It is universally poorly structured as it comes off, because the people building those applications or building those devices don't know what you need, right? And they certainly don't know where you have deployed it. That is a game time, live decision, production rollout decision. So even if it is perfectly structured, the least you could do is add metadata about where the thing is and what it's going on and what the context of it was. This is one of the biggest things that is hurting ML generally. People are like, well, I'm just going to give it an answer, find me a queen, and you're not giving it any context. Were you talking about the Renaissance? Are you talking about beds? Are you talking about whatever, a card deck? That's context. And servers need that too. And debugging needs that too. You need the context of where things come from. So it comes off, it's poorly structured, or it lacks metadata, and then it all has unreliable connectivity back to your data warehouse. And you're like, well, no, you don't understand. We're all on whatever, Google or AWS or Azure or whatever. Nope, wrong. Those things go down all the time. Actually, entire zones go down occasionally, and no harm to AWS. It happens to everyone. But no, the networked protocol, TCP, is built to have unreliable connectivity. That is how it's built. It's built to survive a nuclear war. And that means that things like retries and restarts and dropped packets and so on and so forth. That is what I mean by unreliable connectivity. It's not a direct connection. I mean, arguably, even to your disk, you have unreliable connectivity, but at a completely different order of magnitude. Most data shipment tools are not built for this, right? They just assume that data got there. And that's why you need to be thoughtful about how to store it locally, and then thoughtful about how to ship it and retry it and so on. And then you store too much, and then ultimately, let's say something bad happens, an alert happens, then you have to wait until the data gets to all the way to the end of your pipeline before you can take action on it, right? Which again, just slows the overall process. So after you set up this kind of thing, and again, my company helps set this up, so again, we are open source and so on, but this is a general playbook. When you see these little logos for Expanso, that's what I mean. But you set up an iceberg table. They are nearby the devices, the machines, or on the cluster itself, or like I said, nearby. They might store things in a local iceberg table. They might be a single VM. It could just be a Raspberry Pi. It could be whatever you like. But now that takes ownership of landing the data locally. It doesn't mean you're not still passing it through, but you're doing portions of your ETL job left. You've shifted that left. And by doing that, like I said, you give much more clarity and visibility and so on. And by the way, it now enables that distributed compute that I was talking about earlier. So you can now say like, hey, you know what? On all of those near compute machines, I want you to issue the following query. Give me all the transactions from the last hour or something like that, right? But I don't want the aggregated versions. I want the raw, whatever, stack traces or whatever, because something is broken. So you're able to do that now because you're storing it all locally. Again, if you just push that back to a central repository, you're in for a bad time. If you'd like to implement that, please take a scan. Okay, playbook number 2, speed of light is constant. So again, I like to joke, speed of light isn't getting any faster. Hasn't gotten faster so far, maybe in the future, but seems unlikely. And when you do that, you can say with some authority that in 10,000 years' time, a ping between New York and LA round trip will be 80 milliseconds. That's it, right? If you need to make decisions in under 80 milliseconds, you're for a bad time. But even if you aren't, right? Let's say you're not, maybe it's not a single decision. Maybe it's a series of 3 or 4 that you put together. If your system has to go back and forth to that data warehouse, once you get 3 or 4 of them wired together, you're starting to talk about things that human beings can actually pay attention to. And by the way, machines want it to be much, much faster than that, right? So anytime you're talking about real time, and again, I'm not saying, okay, I'm driving a car and this needs to avoid an accident. Really, like I'm talking about applications that simply want to connect things together. I consider that real time. Basically, anything under 5 seconds is real time. And right now you have this stream of noisy, unstructured data, all of which this fire hose is being sent over what I call a long distance call. So you're paying to ship it, it's taking too long, and your central clusters have to be over provisioned because they are receiving the maximum peak of your fire hose, right? Because even if they are anything less than a provision for the peak, that means you're starting to get slowness in the middle of the day. So a better solution is to store and query that data in place, where you're able to process locally at the source. You ship answers, not the fire hose. So you could say, hey, you know what? I just want an average of the number of people in my store over the past 5 minutes. This is a real case scenario that we ran into. We are working with a very large satellite provider, or not satellite, excuse me, solar provider in Southwest Australia. They have 15,000 microgrids across the Southwest Australia. Each microgrid has an inverter on it. Each inverter is generating data on a per second basis, okay? They're trying to do modeling about whether or not things are up and down, and what they've discovered is they only need notice every 10 minutes, right? Which is fine, perfectly reasonable, right? If the thing is going down over 10 minutes, then they put someone on a truck. Putting someone on a truck is very, very expensive. They're sending 1 per second, but they only need it every 10 minutes, meaning they are, by definition, sending 600 times too much data, right? If they could just average it before they move it, they're already saving. And because they're over, in this case, 3G, it's even slower. But that's a perfect example where it's like, hey, do a little bit of work on the front end. Doesn't mean you're throwing away the data. And it doesn't mean you're not even shipping that data, just do it, less, or do it to a place that it can move to and sync overnight or whatever you want. So ship the answer, not the fire hose. You could achieve true real time by paying attention to that data and actually taking action. Hey, this is down, and I've gotten 3 down notices over the past minute. I'm actually going to actively pull it from the load balancing pool, just because proactively, and I'm going to notify everyone. I didn't have to wait until that got through my Splunk pipeline or my Snow pipes or my whatever in order to make that decision. I could just pull it right now. And by the way, you also are reducing your overall costs in storage, cost in centralized compute, so on, which does tend to be much more expensive. There are lots of ways to attack this problem. Again, my company focuses on edge data orchestration and things like that, helping putting agents in these places in elegant ways. They should be lightweight. They should be incredibly encapsulated. They should allow people not to have to rebuild anything in new SDKs and things like that. But then you also need, once you put that agent there, you're going to need an efficient stream processor in order to pick up that stream as it happens. They tend to be much lower in volume, but still they are full streams. And of course, an embedded query engine. I do strongly recommend. I'm a huge fan of the enormous open source projects DuckDB and SQLite. They're wonderful. Get your stuff in there. Or if you just want to store it locally, you can use a Parquet file or Iceberg and do efficient things there. The way it looks, here, for example, you have all these machines. They may all be running, who knows, in a single zone. Their default is just whatever's shipped the stream, once a minute, once a second, whatever, push it into my interim storage, my bronze tier. Then I onboard that into my database, and then I finally get answers when it gets all the way to the end. Shipping it even in that, or putting it even in that warm or hot tier is expensive. Doing real or hot compute is even more expensive. There's got to be a better way. Our recommendation is you put agents on or near the devices themselves, and then you have them do aggregation, or you have them do summaries, or whatever you might like. The rest of your pipeline remains unchanged, by the way, just unchanged. It just magically shows you savings. And by the way, it gives you the option to move things and filter to remove things like PII and so on, and I'll get into that in a second, and put it straight into archival, right? Where it might be, archival per region, archival in a really closed, or excuse me, a lockdown state, and so on. Again, reuse existing tools and do your processing in situ. And this is a real example that we mocked up for a customer. They were spending $2.5 million a year on their SAIM. We came in and showed them how to save 98%. That is not an exaggeration. Like 98%, $2.5 million in a week. Like, it took no time. Now, in full disclosure, they didn't do that. They were like, we're fine actually at 70% savings. And I was like, great, we'll do that. Because they wanted actually a little bit more interactivity, and they wanted those kind of things, which is fine, right? It's up to them. They could just turn a knob and ship whatever they'd like. But what we gave them was the power to do that by just flipping a switch. Instead of having to go re-architect their entire system and add a new backend, and I know you're shipping it to Splunk today, you need to put it into a queue with Kafka or whatever. Again, none of those are bad platforms, but like to ask a data team that's made enormous investments here to change, you're going to be unhappy. You want a strategy session around that? And then finally, regulations and data. Gravity exists. Again, I find it really funny. A lot of people don't realize how, well, first, vague a lot of these things are, like remarkably vague. And second, how likely it is that you are already in violation. So let me give you a little pop quiz here for you. Does anyone in this room move IP addresses from their servers, right? You have a web server up, you're querying stuff. Are you moving an IP address? Anyone? I'm going to assume you all are, and you're just afraid, because I guarantee you are. You're in violation of GDPR today. You are not allowed to move an IP address from someone who lives in Europe over any boundary unless you've removed that last octet. Now again, I'm not a lawyer, go talk to your own, but that is considered to be personally identifiable information if you have someone's raw IP address without the last octet removed. That's the last, whatever, that 0 through 255 at the end. Again, nobody does this. Nobody. They don't think about it. They're like, don't worry, Splunk is, whatever, SOC compliant, and it's good. I'm great. It's not Splunk's job. Like, Splunk's job is to index your data and make it super efficient. It's your job to put in the right amount of stuff at the right PII level. So super important. And once you do that, you get to the second point, which is now your entire data lake is toxic, right? The likelihood of you taking something that is in violation of CCPA or GDPR or take your pick, HIPAA, you name it, and allowing a join query between that and something else, congratulations, the new table is busted too, right? Like, again, I'm not saying lawyers are going to be at your door tomorrow, but they're like, you are putting yourself at risk, and this is a really important thing to think through. It's not hard to deal with. It's just something that people often don't even have the tools. So then, and then we get to things like in-transit exposure. If you're storing it even in interim, like, boy, that's a juicy thing for like, a red team to discover. Like, oh, I know it's secure when it gets to the back end, but oh, they actually store it all in an S3 bucket with unlimited read. That sounds awesome. I'm going to go get access to that instead of this other thing over here. And then, of course, reactive auditing. If you're not building in auditing and metadata and lineage up front, you're going to have a bad time. So the theory here is instead apply policy as far left as you possibly can. Sanitize for PII, ensure you understand the data sovereignty issues and that you're keeping things local as much as you possibly can. And by doing this, you can downstream, you can say, hey, you know what? You don't get to get into my data lake unless you have this little tag that says you passed this particular clearance, right? Just that, which again, the data lake people are like, sure, fine, I'll take that. Will make everything so much simpler. And it streamlines your existing pipeline because now you're moving policy out of a place it probably shouldn't have been in the first place. And it doesn't have to be hard. So this is actually pseudocode against our backend, but it really is this easy, right? It basically is, here's the file. I want you to filter this. So in this case, take anything that's not 200, get rid of it. Run the obfuscate function against our IP address. Just turn it into 256, SHA-256. That gives you clearance. You're good. And then push it into this particular lake and send the raw off to this other location. So, that really is all it takes. But you have to have an engine that enables you to do this. You could build this yourself. It's all software, and I'm an open source guy. So again, you can use us. That's great. I would love to talk. Don't use us. You can build this yourself. I promise. It's not that hard. Well, it is that hard. That's why we built a company around it. But it is something you could do if that's of your interest. And use the tools that are already out there today. Open policy agent is amazing. It's a great way to describe this. It is a CNCF standard. Tons of people using it. Declarative policy. Tools like Vector and Benthos are fantastic. Benthos did get bought, but it got forked, so there's an open source version of that. But regardless, the language, bloblang, and their overall processors are terrific. Hundreds of connectors. We support all the Benthos connectors, I should say. And they have all these libraries built in for making PII really easy. But at the end of the day, this pipeline that you see here, you could, again, in an afternoon, you could hand this graphic to GPT, and it'll create you a Benthos pipeline that does this. It's really not that hard. And it's declarative, right? Meaning you can say, on this date, this pipeline ran. And then finally, control plane. Again, small commercial aside, we offer one. There are lots of them out there. Actually, there aren't that many out there. Again, why we had to start the company. But you could certainly build this yourself. There's lots of stuff to do. And so what does this look like? So again, a lot of people say, well, I have a database, and I have separate tables. Probably not compliant. Oh, no, you don't understand. Now I have separate databases. Still not compliant. Oh, I have an ETL that in each region and a database in each region. Now I'm compliant. Probably still not. Again, I'm not a lawyer. Go talk to your own counsel. But from our understanding, that isn't going to cut it. So what do? There isn't a playbook for this. Well, yes, that's kind of true. SOC compliance is, and most regulatory compliance is really, really, really vague. That IP address little fact that I gave earlier, that's something that our lawyers said was true. Your lawyers may say something different, but we said, no, this is pretty clearly identifiable information. But again, there is nothing clear. Talk to your folks. But again, you can, just by building an engine that makes it this easy to add and subtract and change things, you're going to make your life easier. So I like to joke, well, we're almost compliant, and then almost looks like that. So what does it look like? Again, the idea is instead run jobs, run sanitization jobs, run filtering jobs, run schematization jobs, run whatever jobs at the front end, as far left as you possibly can. Use a system that helps you do this in a declarative, repeatable way. But at the end of the day, if you're not doing this as far left as you possibly can, you're probably going to be in for a bad time. Today, tomorrow, I don't want to scare you, but it ain't good. Or you could talk to me for a strategy session and get paid $50. So that's it. The summary of this is, I would argue, if you hear in your organizations or your practice or whatever that you want to ingest it all, don't worry, we'll get it to bronze and then figure it out. That is a red flag. Not even a yellow flag. That is a red flag. What are we moving? Where are we moving it from? How are we moving it? Who's tracking cost? Who's tracking the data? Who's tracking lineage? How do we reproduce what was there? How do we know whether or not whatever this person visited this thing on this day and got a loan finding or whatever it might be? Ingest it all, genuinely a red flag. It's a tax, it slows everything, and it will hurt you from a machine learning perspective. The strategy here is think about what you can shift left as much as you possibly can. Doesn't mean to make it hard. It just means think about everything you have, and you, especially if you're on the data team, take ownership of that. Go to talk to those SREs and so on, and help them figure out how to implement solutions that help them, work with you downstream. I do strongly recommend open source. I'm an enormous fan of this. It doesn't mean only open source, right? It's perfectly fine to use Snowflake and Splunk and hosted cloud and things like that. But there are lots of great open source tools out there to help you get started, and so on. And at the end of the day, I like to say, a lot of people ask us who our ICP is and what their biggest problems are. And we do all of the things that you see here, right? And I say, the benefits you get, I can make it work for almost anyone in your organization. If you're a head of data engineering or a software developer, I bet your problem is team slowness, data cleanliness, so on and so forth. Great, we can help with that. If you're talking to the CIO or the CFO, they're like, oh my God, our data bills are out of control. What do we do? Great, we can help with that. Or you can, the last one is hey, you know what? We'd love to adopt more AI and ML. I hear that's the greatest thing. How do we do it? Great, we can help with that too. So what I would say is the benefits here are enormous, and As far as selling it internally, just understand who you're talking to and see what their motivations are. But we can help with almost all of them. Or a playbook like this can help with also all of them. I always feel bad coming to an open source conference talking about my business at all. I promise you, this applies whether or not it's purely open source. And you say, go fuck yourself, Dave. And that's it. Enjoy.
We have about 5 minutes for questions, so anybody questions? Yeah.
So I was curious, you talked about the shipping of IP addresses and that, what about all these plugins? A lot of us taking this approach of getting the user to waive this, and when we ship that, is that saying that's not a safe approach, or we just need to document that better and with the data as we get it? What's your recommendation?
So can I ask, just to clarify, you're talking about like cookie banners that says like accept all? Yeah, no.
Correct. So you're saying basically those are a false sense of security? What
they are doing, again, I'm not a lawyer. Please talk to your own. My understanding is what they are doing is allowing you to communicate with them. Okay, so that's fine, and that is something you have to get clearance for, right? Because otherwise you cannot do it. You cannot store their cookie. You cannot anything. However, we're not talking about cookie. We're actually talking about when they visit your site, into Nginx it came from this IP address. That is not a clearance thing. And even if you have permission, even if they give you all the permission in the world, they're not giving you permission to leave a region with their data in unobfuscated form.
That's not waivable?
That is not waivable.
All right. That was the question there.
Yeah,
because surely the policy would allow them to say the cookies, and yes, that we'll move and use your data, but you're saying that there's no way in a cookie banner to get that.
Talk to your own attorneys. Generally speaking, if it can be identified as a single human being, it should not leave a region, including a state, by the way. But we have 50 states and 50 different policies, so I wouldn't go that far. That said, the language is vague. Again, I like to. I know that I've talked about a lot of different things here. Solve this from a cost perspective. I guarantee, your CFO is gonna be like, wait a second, you use maybe $500,000 a year, great. And then behind the scenes, you're also solving these other problems. Awesome, right? So take whatever angle you like. My understanding is no. Please talk to your own attorneys.
Cool. I think that's it. Thank you so much, David.
Thank you.